Hey Simon, thanks for responding. I wanted to, I'm just flooding with ideas and information on this, but I'm going to try to say something about where I am with this, just so that you're clear, and just so we can communicate on the same wavelength. The the thing that I bring up about what are the stars, this is just kind of jostling things. I'm basically just calling into question our interpretation, our understanding of what is actually out there, just based on contradictions in the model that we have for the nature of space-time and the model that we have for the nature of light. There's a contradiction there with respect to our notion of what is in outer space, of what the stars are. We don't factor into our equation of what's out there the light that would be returning from the curvature of space from our own sun. In its persistence, we assume that there is this persistence of the light from stars that are billions and billions of light years away. Not billions and billions of miles, billions and billions of light years. That's an incredible, incredible distance. And we assume that the light persists in that billion light year journey all the way to the Earth. Yet we neglect the conservation of the energy that comes from our own sun just because we don't see it. Just because from an angle we don't see all the light that's shining out in all the other directions. And it's a conceptual problem. It's just as flawed as the issue with the flat Earth. Oh, you don't see the edge of the Earth, it must be the end of it. And so space-time is curved. We know that space-time is curved. That's why the Earth appears as a sphere. It's built into the nature of space and time. If you wrap your head around what space is, you notice that space doesn't exist without time because there's no scale for it. There's no way to measure space without time. And so what I'm saying isn't a conclusion. I'm not concluding that what that is that everything that's out there is the light from other stars. I'm not concluding that. And I think, in fact, what I'll tell you is that where I am with it is a very, very different place. This was a stepping stone for me. For me, this was a stepping stone. And so when I realized that we had missed something fairly serious in our notion about what is out there, I started calling a lot of other things into question. And so where I've gone with it is kind of hard to get to scientifically, but there is a path. There is a path to it, and so that's what astrotometry is. This model that I presented isn't astrotometry. Astrotometry is something else. But you need to understand this kind of to get there. I'm trying to provide a way to, shake the groundwork to allow the movement that someone would have to rationally, logically go to. And these contradictions, our worldview, as it turns out, is wrought with these scientific contradictions, where science has two views that haven't been reconciled into the picture, into the model that we believe we have because of our perception of things. And so it's a perceptual issue. And but the bigger picture here, is that this is a step. This isn't a conclusion. And if you and I want to present my philosophy on this. I don't own any of this. I don't claim to own any of this information. These are observations that I've made about the world, and I'm putting it out there because I want to share them. And if you want to take this and you want to try to make a model, if you want to do a mathematical model, that's what I was thinking. I was thinking that you might be really interested in this because of the thing that you did with the stars. And if you wanted to do some type of a simulation where you're actually studying the interaction of light with the curvature of space-time. And if you want to do a simulation of that, I would love to see that. And if you if you win a Nobel Prize for it, more power to you. I mean, don't call it astrotometry, because really astrotometry is something very different. And but if you want to take the ideas and run with them, Godspeed. I know you don't believe in God, but anyway, the thing is, it's I don't feel like I own this information. This is stuff that I feel very fortunate to have come up with, to have come to understand. But this isn't property per se. Astrotometry, the word, I'm considering my property until I'm comfortable with what it is, and then I'm going to throw it to the wind. That's my plan. But right now, it's a trademark. It's kind of like I'm wanting to make sure that other people don't go out and say, "Oh, this is astrotometry. Oh, this is astrotometry. Astrotometry water." No, I don't want that. And it's just the problem we have with quantum mechanics. You've got all these people that are saying that quantum mechanics supports their idea, or supports their whatever. And it's just terrible the way that quantum mechanics has been. Well, there's too many interpretations, and so everyone wants to call what they're doing quantum mechanics or quantum mechanical or whatever. And so I just wanted to avoid that. I wanted to avoid that kind of problem with astrotometry. And so for now, I want to keep it mine. But the ideas are not mine. Even though I've come up with them, I don't consider them my property. I don't consider observations about the universe something that someone should coddle. And so, if you want to take this and model it, I would love to see what happens. I think that what you're going to find out, though, is that what I'm saying is very much a serious issue with our understanding of what would be happening with the light. In other words, I think what what you would see in your simulation is that depending on where the light left from the sun, in other words, there is a natural attractor or escape, using the fractal terms, the fractal term attractor, the fractal term escape. Depending on what degree, what angle you're moving away. And then you picked up immediately on the fact that 4 billion years ago, the sun was in a very different place than it is now. That's a very important point in this analysis, because 4 billion years ago, supposedly the sun was much closer to the center of the universe where the Big Bang happened. 4 billion years ago, it's kind of moved out from that space. But that movement, don't get caught in the trap. If you want to analyze this, analyze it in a pure form. Don't get caught in the trap where what you're seeing, what you're thinking about the nature of space and time and where the stars are, and where they've come from, is all derived from this notion about the speed of light, and is all derived from this notion that assumes a straight line path for light through space, which we know isn't right. And so